Okay. Bismillah ar-Rahman ar-Rahim. Inshallah, today I will cover limits at infinity 4.5. Mainly what we have in this section, we are checking the function as it goes to infinity and the function as it goes to minus infinity. What is the limit as this goes to infinity, and what's the limit as it goes to minus infinity? And we call y equal L is a horizontal asymptote if the limit is goes to minus infinity with the function equal to L, or if the limit is goes to infinity is equal to L. That means what? These two, maybe they are the same, maybe they are different, maybe they does not exist. So the number of horizontal asymptotes are either 2, if these two are different, they are values, but they are different. 1, if one of them exists, the other one does not exist, or they are equal to each other. 0, if none of these two limits exist. So these are the three cases, or these are the three possibilities for the number of horizontal asymptotes. Either we have 2, or 1, or 0. Okay, now let us check horizontal asymptotes for different functions. This is what I will do, then we'll solve problems. If I have a 0, a constant over x to the power r, then this limit, it will be what? And then it will be 0 over infinity, which is 0. I mean, a constant over infinity, which is 0. And the same thing here. But you need to be careful here for the negative. You want r, since r it can be any rational number, you want this to be defined somehow. It's valid only if x to the power r is defined when x is negative. So I don't have a square root of a negative number. R should be, yeah, not like this, not half. If half, then I have a problem. Also for the exponential function, you notice for the exponential function, if f of x equal e to the power x, what will happen? This is the function. As x goes to infinity, what is the limit of e to the power x? As it goes to infinity, I'm going where? I'm going to infinity. This is infinity. So we don't have a horizontal asymptote here. However, check as x goes to minus infinity, what will happen? The function will do what? It will be equal to 0. So I have y equals 0 as a horizontal asymptote. Or this exponential function. So guidelines how to do this limit for rational function? It's very easy. If the degree of the numerator is less than the degree of the denominator, then the limit is 0. Either x goes to infinity or x minus infinity. If they are equal, the degrees are two, the numerator and denominator are equals, then the limit will be what? The ratio of the leading coefficients of both numerator and denominator. If the degree of the numerator is greater than the degree of the denominator, then the limit does not exist. It may go to infinity, it may go to minus infinity, it may does not exist, and we'll see examples. This is no need for it. This is just the definition, the formal definition of the. For the constant function, if you think about the constant function, assume constant function k. What will the limit as it goes to infinity? I'm still with k, so the limit is k, and minus infinity, the limit is k. For the function x, this is the function x. For sure, as I'm going to infinity, the function is going all the way to infinity. And as it goes to minus infinity, also I'm going to minus infinity. For this function, 1 over x, if you know the graph, it will make it easier for you. As x goes to plus infinity, the function is going to 0. As x goes to minus infinity, the function is going to 0. So do we have a horizontal asymptote for this function, 1 over x? Yes, it will be y equal 0. This is what we did before. As I said, for minus infinity, I need r. I mean this x to be r to be defined. I don't have square root of a negative value. Now for the polynomials, I'm dealing with different functions still. For the polynomials, what will happen? The limit, if n is positive, then I mean x to the power n, for x to the power n, not for the polynomial, for x to the power n. If n is positive, it will be infinity. as x goes to infinity. If n is negative, so it means the power will be like 1 over x to the power n, where n is, 1 over x to the power something. For example, I want to find the limit x goes to infinity if x to the power -5. Then that will be what? Limit x goes to infinity 1x to the power 5, which is 0. The limit is 0 if n is negative. Exponential we did. Also, we can deal a little bit with this exponential. For example, this one, I want to find this limit x goes to 0 from left, is 1 over x. You notice this is the graph for 1 over x. So as x goes to 0 from left, 1 over x goes to where? 0 from left, 1 of the left goes to minus infinity. So e to the power 1 over x, and this goes to minus infinity, this goes to what? It will go to 0, as we did before, which is similar to this one. Sin x, what's the problem with sin x? This is sin x. I want to do either plus or minus infinity, it's the same idea. I don't know where it will stop. So there is no value it will reach. I don't know where it will stop, so the limit we say does not exist, which is similar to that oscillating. It will it's between -1 and 1. Tan inverse of x, which is a special function. Tan inverse of x, this is the graph for tan inverse of x. So very clear, as it goes to infinity, the tan inverse goes to pi over 2 from infinity. Minus infinity, it goes to minus pi over 2. So I'm trying to give you some dealing this x goes to infinity, x goes to minus infinity for different functions. As we said, for the polynomials, it will make it easier for us if we deal with the polynomial. And instead of deal with all of this function, I can deal only with the first, with the one with the highest power. Why? I can take x to the power n common factor, and all of this will be 0. Since it will be constant over x squared, constant over x to the power n, as it goes to infinity or minus infinity, all of this will be gone. So I have only an x to the power n. So to discuss this, it's similar to discuss this limit. To discuss this limit, I mean, it will be similar to discuss this limit, so you can check it plus or minus infinity. The same thing for rational function, the same idea. I can do it for the numerator and denominator. So to do all of this limit is similar to do this limit, where it's easy now to decide. If the degree is different, if the degree of the numerator is less than the degree of the denominator, so it means this is less than this, then I have 0. If they are equal, خلاص cancel, I have this. If they're not equal, then it will be either plus or minus infinity. It depends on the sign. As x goes to infinity or minus infinity, also it depends on the sign of these numbers. And I will take examples later. Also, we need to be careful when we deal with the limits. Not always the limit as it goes to infinity minus infinity, it goes to a number. Sometimes it goes to infinity and minus infinity, like in this case. So we say infinite limits at infinity. Okay. Now we'll deal with these problems. Like in this one, if you notice, this is tan inverse the continuous function. So you can take the limit inside. So that will be tan inverse of the limit as it goes to infinity of 1 minus 5x squared over 3 minus 5x cubed. Here, very clear, the degree of the numerator is less than the degree of the denominator. So this limit is what? This limit will be 0. What is tan inverse of 0? It will be 0. So this is the answer. This one, you need to do some calculation. If you substitute, what you will get? This is infinity, but this is minus infinity. So you're getting infinity minus infinity. Be careful with infinity minus infinity. Infinity minus infinity means undetermined. Undetermined means like you're back to square one. Nothing. You cannot conclude anything. You need to do something. You need to manipulate the function so that you can decide easily. One of the things they can do, make it over 1 and just rationalize it. 9x squared plus 6x minus 3x over the same thing. Let us see what will happen. This will be what? The denominator is this. What about the numerator? It will be 9x squared plus 6x minus 9x squared. This is cancelled. Oh, don't forget the limit. This is still the limit. Huh? Limit x goes to minus infinity. And that will be what? Limit x goes to minus infinity, 6x over. I will do something here. I will take x squared common factor. What is the remaining? 9 plus 6 over x. You can always check. This times this, you'll get this, get back. This is minus 3x. Okay, continue. When I take this x squared out, it will be square root of x squared. What is square root of x squared? Absolute value of x. Don't make it x, especially that x goes to minus infinity. So this will be absolute value of x, square root the remaining. 9 minus 9 plus 6 over x will not make a difference, minus 3x. Now this absolute value of x, since x goes to minus infinity, so it means x is always negative, this will be minus x. Now take a common factor in the denominator, what you will get. I can take x of what? I have minus square root 9 plus 6 over x minus 3. Yes, I took x as a common factor. This x will cancel with this one. So what you will have? You have, now I can distribute the limit. This is will go to 0. 6 over infinity, minus infinity or infinity, who cares? 0. Then it will be 6 over minus 3 minus 3, which is minus 1, which is this one. You want to check all horizontal asymptotes. So I need to do what? Find the limit. This goes to infinity. And find the limit. This goes to minus infinity. That's it. This section, this is what I need to do. X goes to infinity, x goes to minus infinity, all the way. خلاص. Let us do x goes to infinity. It's the easier one. It will be what? I know that. Don't forget. For the exponential function, as this goes to minus infinity, I'm getting 0. As this goes to infinity, I'm getting infinity. خلاص, this is will be e to the power minus infinity, which is 0. So I have 0. Can do it here to save place. That will be 0 plus 1 over 0 minus 3, which is minus 1 over 3. So this is, I can't choose. This is the answer for sure. So I have y equal minus 1 over 3 as the horizontal asymptote. Now I'll check limit x goes to minus infinity for the same function. 4 is minus x plus 1 over 2 is minus x plus 3 or minus 3. Be careful here. If we substitute, you will get 4e to the power infinity, which is infinity. As x goes to infinity, I'm going to infinity. So I have infinity over infinity. Infinity over infinity is still undetermined. So it means I need to manipulate the function. One idea to do this, you take a common factor. Take e minus x common factor. The remaining is what? 4 plus e to the power x. Always you can check. This times this is 4. This times this is e to the power 0, which is 1. خلاص, I'm doing fine. We'll do this also. Take e minus x. What you are getting? 2 minus 3 e to the power x. Now this I can cancel this one since they are the same. So that will be what? Now these things will go to 0 since I'm dealing with x goes to minus infinity. E minus infinity is 0. So I have what? 4 over 2, which is 2. So I have y equal, that means y equal 2 as a horizontal asymptote. So I have y equal 2 and y equal minus 1 over 3, and this is the answer. This one I need to do it, but if we just substitute, what you will get? You will get here infinity minus infinity. So you cannot conclude anything. So over 1, rationalize, and do the calculation, like what we did before. These things, always you will see it. This is will be, don't forget the limit. As it goes to infinity, the denominator is this. Numerator, it will be about x squared plus 4x minus x squared. So I have limit, it goes to infinity, 4x over, I'll do the same. We'll take x squared common factor. It will be 1 plus 4 over x plus x, where it will be limit, it goes to infinity. Don't forget, square root x squared is absolute value of x. That gives me 4x. Here it takes square root of x squared, which is absolute value of x. It will not make a difference since I'm going to x infinity. Huh? So this is will be x plus x. So that limit will be what? 4x. I take x as a common factor. Remaining is what? 1 plus 4 over x plus 1. These cancelled. Substitute. You have 4. This is 0. 4 over infinity is 0. 4 over 1 plus 1, which is 2. Equals 2. Yeah, the answer is 2. The horizontal asymptote of this function, I want to check what are the horizontal asymptotes of this function. If you notice, I can take x squared common factor. Actually, if you think of it, this is the power is what? 2 over half, 2 times half, which is 1. The power here is 2. So for sure it will be, the numerator is, the degree of the numerator is this time the degree of the denominator. So the limit as it goes to infinity minus infinity is 0. But also we can do it in details. We say this one will be what? Square root. I can take x squared common factor. Or I want to find the limit. Limit either x goes to infinity. Or let me just simplify f of x. Square root x squared 3 plus 3 over 2x squared. خلاص. Here I have x, 3x minus 6. So that will be what? Absolute value of x, square root 3 plus 3 over 2x squared over x times 3x minus 6. You notice now, limit, as this goes to infinity, this one will be x, x. So I'm having what? This is cancelled. I'm getting what? Here we have square root of 3, and here we have what? 3 times infinity minus 6 infinity. So I have a value over infinity, so this is will be 0. The same thing, if we are doing limit x goes to minus infinity, what will be the difference? That will be minus x. Square root 3 plus 3 over 2x squared over x, 3x minus 6. So this is cancelled. Still, I'm getting a value minus the square root of 3, and this goes to 0. And this is will be infinity. So a value over infinity, and that will be 0. So the only horizontal asymptote is y equals 0. Okay. You want to find the horizontal asymptotes of this function? We'll do the same. Here I will start with minus infinity, since it's easier. So minus infinity will make it 0. Make these things 0. Khalas, I'm gone. As I said, to check horizontal asymptote, infinity minus infinity. That's it. So that will be 0 over 0 minus 5, which is 0. We'll do the same for limit is goes to infinity of the same function. What is the trick here? I will take common factor, which is e to the power x. It's already ready in the numerator. In the denominator, take e to the power x. You have what? 3 minus 5 e minus x. You can check it always. This times this will give you this. خلاص, this is cancelled. Substitute. It will be 4. These things will be 0. As it's got e to the power minus infinity is 0. It will be 4 over 3 minus 0, which is 4 over 3. So my answer is what? Is this one. This one you want to check. Yeah, if you substitute, you have infinity minus infinity. You have difficult things. So I need to do what? Rationalize. Let us do the rationalization. Rationalizing the denominator to get rid of that, so of the square root. Let us see what will happen. It will be 4x squared. No, rationalizing will not make it. No need to rationalize. Will make it complicated. What I will do, I can take common factor. It's ready. I can take common factor of the denominator and numerator. Let me see what will happen. I don't know if it will work or not. Let us see. I can take x squared common factor here. So I have 4 plus 3 over x. This is the numerator. The denominator, I want to get rid of this x to the power 4. So we'll take x to the power 4 common factor. You have what? 1 plus 9 over x to the power 4 plus x squared. Okay. Now, this x goes to minus infinity. خلاص? I'll take this out. So I have square root. Let me do it here. Square root of x to the power 4. That will be what? Absolute value of x squared. But this is always non-negative. So this is always will be x squared without a minus sign. Always. For any x, that will be x squared. Since x, what it positive and negative, with the square, it will be positive. So I take it out as is. So this is will be limit. X goes to minus infinity. X squared 4 plus 3 over x. Here I have what? Square root of x to the power 4. Take it out. That will be x squared. So we did it without doing any rationalization. Plus x squared. Now we'll do common factor in the denominator, and we get rid of x squared, and that's it. We get answer. That I took x squared common factor. What is the remaining? 1 plus 9 over x to the power 4 plus 1. As-salama. This is cancelled. Substitute. You get 4. Here we get, this is 0. This is 0. So you have 1 plus 1, which is 4 over 2, which is 2. So the answer is 2. This one, same idea. No need to rationalize since it's actually 1 square root. So we can do the same idea. Take common factor. This will be limit as it goes to minus infinity. I took x squared common factor here. I have 2 plus 1 over x squared over took x common factor 3 minus 5 over x. And that gives me what? Limit as it goes to minus infinity. Here I took square root of x squared outside, but be careful. X goes to what? Minus infinity. So this is minus x. So when I take it out, I have minus x square root 2 plus 1 over x squared over x 3 minus 5 over x. خلاص. This x cancelled. Now we just do substitution. Since this goes to 0 and this goes to 0. So I have what? Minus square root 2 over 3, which is b. Okay. This function has 2 horizontal asymptotes and no vertical asymptotes, or which one of these? First, notice 3 e to the power x plus 1. This is always positive. This cannot be 0. This is greater than 0. Plus 1, for sure, it will be greater than 0. So this function f has no vertical asymptote. Actually, it's defined everywhere. It's defined for all values of x. Nothing will stop me to put any value of x, because this is always greater than 0. So I need the argument of len is greater than 0, which is always correct. So the only things I'm concerned about is now there is no vertical asymptote for sure. Now I need to deal with the horizontal asymptotes. To do the horizontal asymptotes, I need to do what? Limit x goes to infinity, limit x goes to minus infinity. First, I will do a trick here to rewrite this function. What is x? Is len e to the power x, which is, this is x, minus len 3ax plus 1. So that will be what? Len ax over 3ax plus 1. This is, we know that len x over y is len x minus len y. So I use this properties backward. So this is my function now. Yalla. Check limit. Let me do it minus infinity. As this goes to minus infinity of f of x. As we said, to check horizontal asymptote, I'll check limit x goes to minus infinity. Check I'm getting a number. Alas, it means we have horizontal asymptote. Check x goes to infinity. We're getting a number. We have another cell. Is it the same or different? Then we have a horizontal asymptote. If we're not getting a number, it means the limit does not exist. Okay. So let me x goes to minus infinity. What will happen? I need to check this. Limit x goes to minus infinity of len ex over 3ex plus 1. Len is a continuous function, so I can take the limit inside. That will be len of the limit is goes to minus infinity ex over 3ax plus 1. Be careful here. This limit will be what? This will be 0 over 0 plus 1. So this is goes to what? To 0. Len 0 to make a problem. So this is, so there is no horizontal asymptote. Because this will not go to a value. It will go to minus infinity. So there is no horizontal asymptote from this side, from x equal to x goes to minus infinity. Let me do x goes to infinity. I don't know where I will do it. Yeah. There is no space. Let me make a space here and rewrite this one here. So I need to do limit x goes to infinity of this function, len ax over 3ax plus 1. What I will do, I take the limit inside, but also I will do one trick. Here, I'll take e to the power x common factor. In the numerator, it's ready. In the denominator, I have what? 3 plus e is minus x. Be careful here. These cancelled. These two cancelled. So what will be the limit? Len of the remaining. Now, as this goes to infinity, this goes to 0. So I have 1 over 3. Or minus len 3. Who cares? So it means how many horizontal asymptotes we have? 1 and no vertical asymptotes. From this, minus infinity, we get no horizontal asymptote. I'm not going to a number. I'm going to minus infinity. The limit. So we get no horizontal asymptote. In this one, I'm getting a value, and then I mean a value, I'm getting a k. So we have a horizontal asymptote. If y equal L is a horizontal asymptote for this, then L equal what? First, I can split this into two things, into these two. This is a function. This is a function. I know the limit of this. Either go to infinity or minus infinity. I know limit is goes to plus or minus infinity, x over 1 plus x. This is 1, same degree. No need to worry about. Now I need to check this one. Notice one thing. As x goes to infinity, what I will do squeeze here. I know that sine x. Actually, you can't do it by manipulation, but let me. Yeah, with this one I can't do it with the squeeze theorem. The other one I cannot, but we can manipulate it a little bit. Sine x between minus 1 and 1. Well, the idea is what? The idea in the sine x is always bounded. it will not go to a specific value as it goes to infinity, it's minus infinity, but for sure it will be a value between -1 and 1. Now, if I took infinity here, e to the power minus infinity is 0. 0 times any value is 0. The same thing as it goes to minus infinity, this will be what? This will be e to the power infinity, which is infinity. Infinity times any value, it will not, the limit does not exist. Okay, this one I can do it by a squeeze theorem. So we say multiply by e to the minus x, which is always positive. So no change in the inequality. As it goes to infinity, this goes to what? 0. This goes to 0. So for sure, this goes to 0 by sandwich theorem. So for sure, I have, if I want to do the limit, as this goes to infinity, of f of x, it will be the limit of this, which is 0 plus 1, it is 1. So I have y equal 1 is a horizontal asymptote. Is I'm sure about. Okay. Now for the case, x goes to minus infinity. As I said, sine x is always a value on this interval between -1 and 1, -1 included. Now, this one, e to the power minus x, as x goes to minus infinity, will go to what? Will go to infinity. Infinity times any value, so the limit, conclude the limit as this goes to minus infinity, minus x sine x does not exist. Since it goes to infinity minus infinity, still it does not exist. So I have, this is, does not exist. So we cannot conclude any horizontal asymptote as x goes to minus infinity, but as x goes to infinity, we conclude there is one horizontal asymptote y equal 1. So what will be L? L will be 1. So this is the answer. I hope it's clear. Now he link the greatest integer with the limit as it goes to minus infinity or infinity, who cares? I think with infinity too, there will be a problem, but with the minus infinity, okay. Now, do it step by step. This is 1 over x. This is 1 over x. As x goes to minus infinity, as x goes to minus infinity, 1 over x goes to what? Minus infinity, it's going here. This is minus infinity. Note, minus x, 1 over x goes to 0 from left. Goes from to 0 from left. That means what? When you do greatest integer to a value 0 from left, like value is minus 0.0001, what will be the greatest integer of this? It will be minus 1. So this will be minus 1. That will be the answer. Just assume I want to find the limit is goes to infinity for the same function. It's not part of this question, but we can do this. Notice x goes to infinity. 1 over x goes to where? Goes to infinity. Goes to infinity. I'm going to 0, but here 0 is what? Plus. 0 is plus. So greatest integer of x, 1 over x, goes to where? 0 plus. What's the greatest integer of 0 plus? 0 plus means 0.001. That will be 0. So if we want to find, yeah, that will be 0. So this function has how many horizontal asymptotes? 2. I have, this is y equal minus 1 horizontal asymptote here, and y equal 0 horizontal asymptote from here. If he asks about the horizontal asymptote, for example. But here he asks about x goes to minus infinity, but then I'm doing it. I'm doing more ideas. This question, a possible formula for a function that satisfies the following conditions. What he did, he gave you some information. He gave you 5 functions. You can solve it by deletion, by deleting the wrong answers. So, okay, for example, when I say limit is goes to infinity is equal to 0, that means what? All of these are rational functions, polynomial or polynomial. That means the degree of the numerator less than the degree of the denominator. It's correct here. It's correct here. This is the first one. It's correct here. It's correct here. Oh, here I need to be careful. This is 3. This is 2 times 1, 3. So it's wrong here. The limit is not 1 here. The limit is not 0 here. Actually, the limit should be -1. So I delete this one. Okay, let us check the other one. Limit as goes to 0 from right. It should be -infinity. Do it one by one. I want to check this. Limit as goes to 0 from right for f of x should be equal to -infinity. A. What is the limit as it goes to 0 from right for f of x? I'll do what? For a, huh? Let me write the function. X minus 2 over x squared, x minus 3. I know it's an infinity category because it's, if we substitute, you have non-zero over 0. It's an infinity category. Now I want to check positive or negative. خلاص, 0 plus. This will be negative. This will be x squared, so it will be for sure positive. And this one, positive. So the answer is -infinity. So this is okay. This is okay. B. Limit as goes to 0 from right for this function. Do the same. I have non-zero. We substitute non-zero over 0. So I have infinity category. This one will be positive here. Okay. Here it's positive. Here it's positive. So the answer is +infinity, but I want it to be -infinity. So this is rejected. خلاص. B is wrong. This is wrong. C. Limit is goes to 0 from right for this function. This is substitute. You have negative. You have positive. You have negative. So you have +infinity. Also, this one is wrong. This is wrong. D, which should be the correct answer. 0 from right, 2 minus x, x squared, x minus 3. It's still non-zero over 0. So this is positive. This one always positive. This one negative. 0 minus 3. So it's negative, so it's -infinity. So this is correct. So I have now A and D. One of them should be correct. So I will do the last one. Limit is goes to 3 from left. It should be infinity. Yeah. Let us do A. I don't need to do B and C. Limit is goes to 3 from left for this function. Still, I'm getting non-zero over 0. Huh? 3 minus 2 is 1. I have 0 here because of x minus 3. Yalla, we check this. This one is positive. This one is positive. 3 from left minus 3, this is negative. So this is -infinity. But my answer, I want it to be infinity. So this is rejected. This is wrong. Let me be sure. Do D for the last things. 3 from left for this function. 2 minus x, x squared, x minus 3. I want this to be equal to infinity. Be sure. Still, this is non-zero over 0, so I have infinity category. This is negative. 2 minus 3, it's negative. This is always positive. This is negative. So negative, what will be +infinity, which is what I want. So this is my correct answer. I hope it's clear. Need to do it, I mean, function by function. I'm going to do this limit. Since it's a continuous function, I can take the limit inside. So that will be tan inverse of this limit. Okay. Now, how to do this limit? Limit is goes to infinity of this function. One way I can think of it, where is the control? The control is here, the highest power. So this is will be limit, it goes to infinity, x to the power 2.1 over x to the power 2. Since there is the control. You take it as a common factor, then you can kill everything. And that will be what? Limit, as this goes to infinity, x to the power 0.1. But as this goes to infinity, infinity to the power 0.1, this is positive value. So the answer is plus infinity. So all of this goes to what? Plus infinity. What is tan inverse? As x goes to plus infinity, we know this is tan inverse. You always should remember this graph. So as it goes to plus infinity, I'm going to what? Pi over 2. So this is my answer. The graph has two horizontal asymptotes, y equal a and y equal b. Find a plus b. What I need? Check limit. It goes to minus infinity, limit x goes to plus infinity. I'll do minus infinity, which is easier. Why it's easier? You apply it, you have 0, gone. So that will be 1 minus 0 over 1 minus 2 times 0. So the answer is 1. So one of them is y equal 1. Halas, done. This is horizontal asymptote. Now we'll do a limit, x goes to infinity for the same function. That will be what? What I will do? I will take a common factor. If we substitute, you get infinity over infinity. Minus infinity over, it's an infinity over infinity in the category, which is undetermined. So you need to take common factor, e to the power x. That will be e minus x minus 1. You can check it always. E to the power x times e minus x is 1. Okay. And this is minus e to the power x. Now I take e to the power x. I have what? E minus x plus 2. This is cancelled. This one is controlled. E minus infinity is 0. Khalas. So this will be 0 minus 1 over 0 plus 2. So this is what? Minus half. So the second horizontal asymptote I call minus half. So I have 2. So this is called this A, called this B. It's up to you. But for sure, A plus B will be 1 minus half, which is half, which is distance. You want to find the horizontal asymptotes for this function. Be careful with this function. First, I have a value and have sin x. Okay. What I will do, I will do a limit as this goes to infinity. What will happen to the absolute value? It will be equal to x in this case, as this goes to infinity. So x plus sin x على x plus 1. How to do that? There are two ways to do it. You can take it as a whole, or you can do this trick, make x over x plus 1 plus sin x over x plus 1. This is for sure one. This is, you can do it by the squeeze theorem. How? I will do it here. Sin x between minus 1 and 1. Actually, I can do it for both. Infinity and minus infinity. It will be 1. You divide by x plus 1, since this is positive. Who cares? You can divide by it. Khalas. As x goes to infinity, this is 0, and this is 0. So it means this one is 0. So this is 0. So I have 1. This is 1, huh? Same degree. So 1 plus 0, which is 1. This is one thing. Now I need to check limit as this goes to minus infinity. Oh, notice. If x equal minus infinity, this absolute value of x will be what? Minus x. So this is minus x plus sin x over x plus 1. And that will be what? Limit. I can do the same trick. Minus infinity minus x over x plus 1 plus sin x over x plus 1. Do the same trick, squeeze theorem. I know in the sin x between minus 1 and 1. But be careful. It will give you the same answer, but to be mathematically correct, I divide by x plus 1. Since x goes to minus infinity, this will be a negative value. So when you divide, you need to change the sign of the inequality. It will not make a big difference. Now we can return it back. So I can write it 1 over x plus 1 less than. So the positive will here and the negative will be here, which will make no difference. And as x goes to minus infinity, this will go to 0. This will go to 0. So it means this go to 0 by sandwich theorem. Here by sandwich theorem or squeeze theorem. Oops. So this limit is also 0. But this one, it will be what? The leading coefficient is minus 1 over 1. So this is minus 1 plus 0, which is minus 1. So how many horizontal asymptotes we have? 2. I have from here y equal minus 1. This is 1. And I have from here y equal 1. These are the 2 horizontal asymptotes. Don't forget, horizontal asymptote minus 1 is not horizontal asymptote. Y equal minus 1. Horizontal asymptote should be a line, huh? Y equals something. Vertical asymptote, x equals something. This one, as we agreed before, where is the control? The highest power with its coefficient. So this will be the same as this limit. Minus 6 x to the power 5. خلاص. If we apply the infinity, that will be what? Minus 6. You can think of it. Infinity to the power 5. If it is just to understand it. Infinity to the power 5, it's infinity times minus 6. That will be minus infinity. So this will be the answer. What I will do, I take the limit inside. It has many problems inside one problem. Okay, so that will be tan inverse of the limit of this limit. Okay, this limit to do, you need to take common factor. So it will take a little bit time, no problem. So this is, I will take x to the power 6 common factor. So I have 1 over x to the power 6 plus 4 in the numerator. Denominator will take x cubed, common factor. You have what? 1 over x cubed minus 2. Okay. Now, if I take this outside, square root x to the power 6 will be absolute value of x cubed. And that is minus x. Why minus x? Since x goes to minus infinity, so x is negative. Here, forget to write the limit. Limit x goes to minus infinity. So that will be tan inverse of limit x goes to minus infinity. This one, take it out, it will be minus x cubed, huh? Minus x cubed. Just the minus sign, but x cubed it should be. So this will be minus x cubed. The rest over. Here I have 1 over x, I have x cubed, 1 over x cubed minus 2. خلاص, x cubed cancelled. Now I can substitute. You will get what? Tan inverse. Here I have minus. This is 0 on us, and this is 0. Square root of 4, which is 2, over minus 2. So I have tan inverse of 1 is pi over 4, which is this answer. Or horizontal asymptote of this curve. We did it before, but let me do it again. And I decided in this recording, I want to do all the problems. Plus 2 over 3 e to the power x minus 4. I started minus infinity since it will be easier. That will be what? 0 plus 2 over 0 minus 4, which is minus half. Actually, one of them, خلاص, minus half, you get everything, huh? That's the only solution where I have minus half, huh? Sometimes you need to be sure about, but it's good to be sure about the other one. Limit x goes to infinity. I will do it. But I need to do what? One factor. Take e to the power x common factor. I have 9 plus 2 is minus x. Here I have e to the power x, 3 minus 4 is minus x. Kill this one, substitute 9 plus 2 times 0 over 3 minus 4 times 0, so I have 3. So y equal 3. This is the other horizontal asymptote. So I have 2 horizontal asymptotes, which is this one, correct. Limit as goes to infinity of this function. The idea is what? You need to be sure about this. What will be the limit? I need to check first what is the limit. If this one, since I will take the limit inside, it goes to infinity of this. That will be what? Where is the control? The control is here. So this is limit is goes to infinity minus 2x cubed. Be careful. This is infinity cubed, which is infinity times minus 2. So this is minus infinity. خلاص? Now I'll go back. I want to find the limit as it goes to infinity of tan inverse x minus 2x cubed. I'm doing this. That will be what? I can take tan inverse outside since it's a continuous function. This is, we know it, is minus infinity. So this is tan inverse minus infinity, which is, we know it's what? Minus pi over 2. So I have this minus pi over 2. So this will be what? Pi minus pi over 2, which is pi plus pi over 2, which is 3 pi over 2, which is this answer. One horizontal asymptote is this. Maybe you have two. So this is one of them. Let us see. What I will do, I check limit x goes to infinity, x minus infinity. Let us see what will happen. If you first you notice, if limit f x goes to infinity, it will be what? X will have no problem. This will be infinity. This will be infinity. This will be infinity. So I have infinity plus infinity. So this is infinity. So I have no horizontal asymptote from this side. I need to check the other side. Limit is goes to minus infinity of x plus square root x squared plus 2x. Here I have a problem since I have infinity minus infinity here. So it means what? I need to manipulate the function over 1, multiply by the conjugate, and do the calculation. What you will get? Limit is goes to minus infinity of what? X squared minus x squared plus 2x. All there is a minus, make a bracket. X minus, here I can take x squared common factor. I will do it here. I'll do it now, it's okay. 1 plus 2 over x to save time. So that will be limit. X goes to minus infinity. This is x squared minus 2x over x. Be careful here. Square root of x squared will be what? Absolute value of x, which is minus x, since I'm dealing minus infinity. So this is minus x square root 1 plus 2 over x. Clear? I'm taking square root of x squared, absolute value of x, which is minus x. So that will be limit, as this goes to minus infinity, minus 2x over. I take x common factor. The remaining is what? 1. Here minus x is plus 1 plus 2 over x. This x killed. So I have minus 2 over what? That is 0. 1 plus 1, which is 2. So the answer is minus 1. So this is the horizontal asymptote. Y equal minus 1 is a horizontal asymptote. Another len, not that difficult. Limit x goes to minus infinity. Len of this. Clear. If you take the limit inside, you have limit this, which is, you know it, this is what? Same degree. So it will be the coefficient. So this will be len half, or you can write it minus len 2, which is Since this is ln 2 to the power minus 1, we can write it minus ln 2. So this is minus ln 2. This one, substitute, you get infinity minus infinity. There is a problem. Manipulate it. Do the calculation. We did something similar. Yeah. Answer is infinity. My answer is infinity. Okay. This goes to minus infinity. I have infinity minus infinity. But if I take x common factor, it will be minus x, 1 plus 3 over x. Okay, let me continue. See what will happen. Plus 3x plus x. That will be limit. X goes to minus infinity. X square plus 3x minus x square over this one. Unless this is cancelled, I have limit. X goes to minus infinity. That will be 3x over this. Can take x squared common factor. I have 1 plus 3 over x plus x. That will be what? Limit x goes to minus infinity. 3x, absolute value of x, and the square root of x squared is absolute value of x, will be minus x. هذا هيصير minus x في, yeah, هنا I think the problem. Okay, so it's minus x, the square root 1 plus 3 over x plus x. So I take x as a common factor. Okay, I took this minus x, minus infinity, so it will be minus x. So I take x here common factor. It will be minus square root 1 plus 3 over x plus 1. So this is cancelled. And this is 0. So you have a number over 0. This will be minus 1 plus 1. And if you notice, this one will be more than 0 or less than 0. It will be positive or negative. Yeah, it's not easy to decide, but this is, let me write it. Limit x goes to minus infinity. 3 over 1 minus square root 1 plus 3 over x. I wrote it the other way. Okay, now now this is non-zero, this is 0. But which one is bigger, this or this? Notice something. This is a negative value. X goes to minus infinity. So 1 plus 3 over x is less than 1. So this will be negative, will be positive. Yeah, this one is less than 1. Square root of something less than 1, 1 minus something, square root of something, so this will be positive. So that will be plus infinity. I know it's non-zero over 0, huh? Then 1 minus 1. So it will be 0. So this will be plus infinity. It's a little bit complicated. We did the calculation. Here we have this. So now I need to decide. I know it's a number not 0 over 0. So either goes to infinity or minus infinity. I have both. Infinity minus infinity. But it goes to plus infinity. Why? Because this goes to minus infinity. So this number, this will be negative. 1 minus something, it will be less than 1. So for sure, 1 minus the square root of this will be a positive value. So positive or positive give me plus infinity. positive 0, I mean. Okay? So this will be infinity. This one, I'll do the same. Just take common factor. It's an easy one. Also, it's infinity. Who cares? So that will be x squared 9 minus what? 9 over x squared. Over here, x 2 minus 6 over x. That will be square root of x squared is absolute value of x, which is x, since x goes to infinity. So this will be limit, x goes to infinity, x. That's it. Cancelled. This goes to 0. This goes to 0. Cancelled. We have square root of 3, 3 over 2. And that is the answer. Let A and B numbers, real numbers, who cares? Then this limit will be what? If we substitute, you have infinity minus infinity, so you cannot do it. So you need to do what? Rationalization. But you need to be careful with A or B. It's not that difficult, but be careful with the calculation. That will be what? Limit x goes to minus infinity. In the numerator, we have what? X squared plus ax minus x squared minus bx. Let me do it at one step. And this is square root. I can take x squared common factor here to save time. It will be 1 plus a over x. Correct? Yeah. Here the same thing. X squared. You have 1 plus b over x. What will happen? This is cancelled. This is a minus b. The numerator is a minus b times x over. Here, square root of x squared is what? Absolute value of x. But I'm dealing with minus infinity. So this will be minus x. So I took minus x from here. Square root this. And also minus x from here. Square root of this. خلاص, we are done. So what will happen now? I will take x common factor. What is the remaining? Minus this. Minus this. So this is cancelled. So I'm getting a minus b over what? Minus 1. This is 0. This is 0. So 1 minus 1 minus 1 minus 2. So it will be half times b minus a. Oops. Half times b minus a, which is this.